Steve drew line segments ABCD, EFG, BF, and CF as shown in the diagram below. Scalene triangle BFC is formed. So remember that scalene triangle means that all three side lengths and all three angles are different. So I'm just going to mark that all three side lengths are different and all angles are different. Just because you always want to mark what's given if it's not already marked for you. And so this question is asking you, which statement will allow Steve to prove that segment ABCD is parallel to segment BFG? So which statement would prove that these two segments are indeed parallel? And remember that when we were talking about parallel lines cut by a transversal, so you can think of these as transversals, and these two as parallel lines, you want to think about terms like alternate interior angles, alternate exterior angles, same side interior angles, same side exterior angles, and corresponding angles, right? So any of those are going to prove that these two line segments are going to be parallel. Okay, so let's go through all of our answer choices because these are multiple choice answers, right? So the first one says the angle CFG is congruent to angle FCB. So let's mark those angles. CFG is right here, and FCB is right here. Well, what do those angles look like to you? If I extended this transversal right here, right, this is my transversal that cuts through these two parallel lines, then these are really just our alternate interior angles because they're inside the parallel lines and also they're on opposite sides of this transversal. That's why it's called alternate, because they're on opposite sides of the transversal, and they're interior angles because they're inside the parallel lines. And so that's actually our answer, because these are going to be alternate interior angles. And we know that alternate interior angles are always congruent when we are given two parallel lines.